Hello everyone, welcome to my fourth session on circles, and in these sessions I am discussing the NCERT problems related to the circles for the class ninth. So all the students who are preparing for geometry sections for any competitive exam, this session will be helpful to them. Along with them, all the students who are class 9 students of CBSE and class 10th of ICSE board, this session will be helpful for them. So in this session, I'm going to discuss couples of problems which are given in exercise 10.6 of NCERT book. So if I open NCERT book, you can see this NCERT exercise 10.6 optional. So before that, already I've discussed these questions. All these questions of NCERT are related to the chapter circle. Already I've discussed that questions. I believe you have gone through all my previous videos. So in case if you have not seen my previous videos, I'll request everyone first see those videos and then you can come to this fourth session of the video. So in this session, I'm going to discuss these questions which are given for the NCERT for the exercise 10.6, which are optional. So you can see this question number one. So prove that the line of centers of two intersecting circles subtend equal angle at the two point of the intersection. That I need to prove. So if I see this question, so here in this question, so you know that two circles, question number one. So in case if two circles are there, so in case if two circles are there, suppose the point of intersection is P and Q. Fine. So P and Q are the point of intersection. Okay, so prove that the line of centers of two intersecting circles subtend equal angle at their two point of intersection. So suppose the centers, suppose this is O and this is O dash. The question is that I need to prove that this angle, I need to prove what I need to prove. So I need to prove that this angle, angle OPO dash, that should be equal to this angle, angle OQO dash, that should be equal to this angle, that should be equal to this angle that should be equal to this angle OQO dash. This I need to prove. Okay, now so this, if you join them these line, this will become the chord. So if we join P and Q, it become a chord. So you know that a line from the center always bisect, a perpendicular line from the center always bisect the chord. Okay, so now if you consider this triangle, now consider the triangle. So here consider this triangle O P O dash and the triangle O Q O dash. You consider these two triangles. Now in this triangle, OP is equal to OQ because they are the radius. Similarly, O dash P will be equal to O dash Q because they are the radius. Okay, and O dash is common. Okay, common side. So they are the common side. So the triangle OPO dash is congruent to the triangle OQO dash. So if they are congruent, so if they are congruent, so then the angle OPO dash that will be equal to the angle OQO dash. Fine. So I hope you understood this. This was the question number one. Now see the question number two. Question number two. Now Now the question number two. So this is question number 2. Okay. Now in this question, two chords are there. So two chords AB and CD of length 5 centimeter and 11 centimeter respectively of a circle are parallel to each other and are on the opposite side of its center. Are on the opposite side of the center. So two chord AB and CD. So this chord. So the chord which is a bigger length that would be more closer to the center. Suppose the center is O. So two chord AB. So here AB is of 5 centimeter and CD is of 11 centimeter are parallel to each other. So here AB is parallel to CD. Okay, and they are in opposite side of a center. Okay, so if the distance between AB and CD is 6, so perpendicular line if you draw from the center, so radius is suppose R, suppose this is D, and if you draw a perpendicular line from the center, so suppose this is OE, you know that it will bisect. So let OE is equal to D. Okay, so then this is OF, this is also R. So then OF will be equal to 6 minus D. OF will be 6 minus D. And you know that perpendicular line from the center bisect the chord. So CD was 11. So this will be 11 by 2. Okay, and AB is 5. So this would be 5 by 2. Okay. So now if I equate the R, so I can say R square is equal to D square plus 11 by 2 whole square. Then this is equal to 6 minus D whole square plus 5 by 2 whole square. Means D square plus 121 by 4 is equal to 36 plus D square minus 12D plus 25 by 4. So D square get cancelled. So 121 minus 25. So 121 minus 25. So 121 minus 25. This is 6. This is 96. So this is 96 by 4 minus 36. Okay, that is equal to minus 12D. So I can say that 12D is equal to 90 minus 96 by 4 plus 36. So all are divisible by 12. So I can write D is equal to minus 8 by 4 plus 3. So this would be D is equal to how much? This is minus 2 now. So 3 minus 2, this would be 1. The value of D is equal to 1. Okay. So this is the value of D. Now they're asking the radius now. So what is the radius? So what is R? The R value is the square root of D square plus 11 by 2 whole square. So the R D is 1. 1 plus 121 by 4. So the value of R is root of 125 by 4. So the value of R is 5 root 5 by 2. This is the value of R, 5 root 5 by 2. Anyone, any doubt, any question you want to ask? Very simple problem. Now see the question number third. So the length of two parallel chords of a circle are 6 and 8. If the smaller chord is a distance of 4 centimeter from the center, what is the distance of other chord from the center? Question number third. The length of two parallel chord are 6 and 8 centimeter. So I'm assuming both are away from the center. So it's not like both are within the same side of the center. So the length, suppose this is the circle. So the length of two parallel chords are 6 and 8 centimeter. Length of two parallel chord are suppose now 6 and 8 centimeter. So suppose this is AB and this is CD. So you again draw the perpendicular line from the center. This would be 4. This would be 3. AB is 6 and CD is equal to 8 centimeter. Okay, suppose this is center O. Okay, this is R, this is R. Okay, same similar type code of question which we did before. You know that perpendicular line from the center always bisect the chord. The length of two parallel chords of a circle are 6 and 8. If the smaller chord is a distance 4 centimeter from the center, so this is 4. So if this is 4, then this value will be 5. Everyone understand Pythagoras theorem. So that you get the R is equal to 5. Okay, Pythagoras theorem everyone knows 3 square is 9, 4 square 16, 16 plus 9 25, which is square of 5. So what is the distance of other chord from the center? So we just need to find this. This would be equal to 3. Clear everyone? Hmm, very simple. Now question number 4. Now we'll see question number 4. Now we'll see question number 4. Let the vertex of the angle ABC locate outside the circle, and let the side of the angle intersects equal chord AD and CE with the circle. Prove that the angle ABC equal to the half of the difference of the angle subtended by the chord AC and DE at the center. So let me first draw the diagram. Suppose this is the circle. Let the vertex of the angle ABC is located outside the circle, and let the sides of the angle intersects. Let the sides of the angle intersects equal chords AD and CE with the circle AD, AD and CE with the circle. So this is AD, this is ED and CE. Suppose this is B, A, B, C. Hmm. Let the vertex of the angle, let the vertex, suppose this is center O. So let the vertex of the angle ABC located outside the circle, and let the sides of the angle intersects equal chords. Sides of the angle is given. What is given? It is given that the AD is equal to CE. and let the sides of the angle intersect equal chords AD and CE with the circle. And it is given that the AD is equal to CE with the circle. Hmm. Hmm. Okay, so AD is given equal to CE. Now you know that equal angle subtends, equal chord subtend equal angle at the center. So this angle and this angle will be equal because equal chords are there. They subtend equal angle at the center. Okay, now let this is angle 1, this is angle 2. Prove that the angle ABC. So what to prove? What you have to prove? So you have to prove that angle ABC. You have to prove that angle ABC is equal to half of the half of the difference of the angle subtended by the chord AC and DE with the center. So to prove that this is half of angle 2 minus angle 1. And anyway, you know that angle 2 will be bigger than angle 1 because you can see the chord. The chord DE is bigger than chord AC. Definitely the angle subtended by DE would be bigger than the angle subtended by AC. Okay, so to solve this, when we are trying to solve this, so you can see that angle 1 plus angle 2 plus 2 times of angle x, that is equal to 360 degree. Okay, so I can say angle x is equal to 180 degree minus half of angle 1 and angle 2. So angle x is equal to 360 minus angle 1 angle 2, then divide by 2 180. So you can understand this part. This is the value of angle x. Okay, this is the value of angle x. Hmm. Then what else I can say? Hmm. Now I can, what else I can say? Now you know that this O is a center, no? So OA will be equal to OD. Okay. So if this is suppose if this is Y, this will be also Y. That would be isosceles triangle. If this is M, this will be also equal to M because OC will be equal to OE because the radius. OA will be equal to OD because the radius. So you can say that what is the value? You can say that now I can say that 2y, then I can say that 2y plus x is equal to 180 degree. So the value of y is equal to 90 minus x by 2. So the value of y is equal to 90 minus x by 2. Similarly, I can say that the value of m will be equal to 90 minus x by 2. Okay, so you know that. Hmm. If I see this angle, called angle BAO, then it is exterior angle of the triangle. Now if I see this angle BAO, then angle BAO will be equal to x plus y. Hmm. Exterior angle of the triangle is equal to sum of the interior opposite angles. So angle BAO, so this is x plus y. What is y? 90 minus x by 2. So angle BAO is equal to x by 2 plus 90. This is angle BAO. This is 90 plus x by 2. Similarly, I can say angle BCO. Similarly, I can say that angle BCO, that will be equal to x by 2 plus 90. Same logic. So exterior angle of the triangle is equal to the sum of interior opposite angle. Anyway, triangle AOD and COE will be congruent because it is given that this side and this side are equal. It is given already this part. This part is already given to you. So, so now what is required? Now consider this quadrilateral BAOC. So now consider the quadrilateral. Now consider the quadrilateral. Now consider the quadrilateral. Now consider the quadrilateral BAOC. Now consider the quadrilateral BAOC. So if you consider this quadrilateral BAOC, so what are the angle? So the angle for that would be, the angle for the quadrilateral would be angle ABC. This would be angle ABC. This would be angle ABC plus angle BCO plus angle BAO plus angle BAO plus angle AOC, that is angle 1 plus angle 1. So that would be equal to 360 degree. The sum of all interior angles of a quadrilateral is 360 degree. So ABC you have to find it out. BCO, and they are equal to 90 plus x by 2 plus 90 plus x by 2. And angle 1, it is given, this is equal to 360 degree. So angle ABC plus x, so this is angle x plus angle 1, that is equal to 180 degree. Now you know the value of angle x. Uh, so So angle x is 180 minus angle 1 plus angle 2 by 2. So this was angle x. So angle ABC plus, what was angle x? 180 minus angle 1 plus angle 2 divide by 2. This is plus angle 1, is this is 180 degree. So you can say angle ABC is equal to, this is angle 1 plus angle 2 by 2 minus angle 1. So I can say angle ABC is equal to angle 1 plus angle 2 minus of twice of angle 1 by 2. So I can say that angle ABC is equal to angle 2 minus angle 1 by 2. This is what you had to prove in question number 4. Okay, so this was question number 4. Okay, so now now going further, if we see question number 5. Question number 5. So question number 5, this is question number 5. Prove that the circle drawn with any side of the rhombus as diameter. Prove that the circle are drawn with any side of rhombus as the diameter. Any side of rhombus as the diameter. Prove that the circle drawn with any side of rhombus. So prove that the circle drawn with any side of rhombus. Okay, so with any side of rhombus, this is the rhombus. Suppose this is the rhombus. So this is center O, this is A, this is B, this is C, this is D. To prove that the circle drawn with any side of rhombus as the diameter passes through the point of intersection of a diagonal. Passes through the point of intersection of a diagonal. So this you have to find. So you have to find this Q. You have to find what you have to prove. So you have to prove that the point Q lies on the circumference of the circle. Lies on the circumference of the circle. As you know that ABCD, is a rhombus, and in a rhombus the diagonals of the rhombus intersect at the right angle. So you know that this would be 90 degree. This would be 90 degree. Why this is 90 degree? So angle now now so now this angle, now the angle AQB is equal to 90 degree. Why? Two reason. What are the two reason? One reason is the angle formed by the semicircle, angle formed by the semicircle on the circumference is 90 degree, and this is equal to the another property that ABCD is a rhombus, no? So another property is that the what is another property that the diagonals of the rhombus diagonal of the rhombus bisects each other at right angle, bisect each other at right angle. So with that you can prove that the Q lies on the circumference of the circle. It means that the point of intersection of the diagonal of this rhombus that lies on the circumference of the circle. Question number 5. Okay, question number 6. ABCD is a parallelogram. So ABCD, question number 6. ABCD is the parallelogram. Question number 6. ABCD is the parallelogram. Then the circle through A, B, and C. The circle through A, B, and C intersect CD. Intersect CD produced if necessary at E. Prove that AE is equal to AD. This is question number 6. This is question number 6. So in question number 6, what we need to do? So suppose now in question number 6, what you need to do? Suppose there's a parallelogram. Now suppose there's a parallelogram A, B, C, D. Suppose there's a parallelogram A, B, C, D. The circle through A, B, and C. The circle through A, B, and C intersects at D. The circle through A, B, and C intersect the D. Intersect the D. Intersects CD. Produce if necessary at E. So prove that AE is equal to AD. Prove that AE is equal to AD. Prove that AE is equal to AD. Now you know that AECB would be cyclic quadrilateral. Now you know that. Now we know that ABCE is a cyclic quadrilateral. AECB is a cyclic quadrilateral, and you know that ABCD is a quadrilateral. No? So ABCD is a quadrilateral, and ABCD is a quadrilateral. So ABCD. sorry, is not a quadrilateral, it's a parallelogram. So ABCD is a parallelogram. So ABCD is a parallelogram. So hmm, 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 hmm. So now this angle, if this is x, so this would be x because opposite angles of a parallelogram are equal. And if this is x, then this would be 180 minus x. Okay. So because angle AEC and angle ABC would be cyclic quadrilateral, and angle ADC will be equal to angle ABC because they are the opposite angles of a parallelogram. Okay. Now we know that we know that we know that AB is parallel to CD. Now we know that AB is parallel to CD means uh, AB would be parallel to CE. Okay, so the angle EA, so the angle AEAB would be equal to x only. This would be equal to x only. Okay, now it's very easy. Why I was wasting my time? So this is so now angle AEC is 180 minus x. So then angle AED would be x because this would be x because DEC is a straight line because DEC is a straight line. DEC is a straight line. So if angle AED, so if angle AED is equal to the angle ADE, they are equal to angle x. So AD will be equal to A. Now question number 6. Now question number 7. Question number 7. AC and BD are the chord of a circle which bisect each other. AC and BD are the chord of the circle. AC and BD are the chord of the circle which bisect each other. So AC and BD, AC and BD are the chord of the circle which bisect each other. Which bisect each other. Bisect each other means this and this would be equal. Suppose this is E, means AE will be equal to EC and DE will be equal to EB. Okay, so it's given they bisect each other. So prove that AC and BD. So this is because they are the chords, so definitely they are passing through the circle. So what you have to prove? You have to prove. So what you have to prove? So you have to prove this is given. So you have to prove that hmm, AC and BD are diameter. So AC and BD are diameter. So AC and BD are diameter. So AC and BD are diameter. ABCD is a rectangle. So what you can do. So if you join this, now you can, if you consider a triangle AEB and DEC, so So you can prove it through SAS congruency. Okay, so now now triangle AEB will be congruent to the triangle CED by SAS congruency. Vertically opposite angle, this angle and this angle will be vertically opposite angle. So by SAS congruency, so I can say that AB is equal to CD. So I can say that AB is equal to CD. So I can say that. So I can say that AB means equal to CD. Similarly, I can prove that. I can I can prove that triangle AED will be congruent to the triangle CEB. They would be congruent again by SAS congruency. So means AD will be equal to BC. So AD is equal to BC and AB equal to CD. Okay. What I need to prove? I need to prove AC and BD are diameter. So AC is a diameter means ADC should be 90 degree. So you know that AB is equal to to prove ABCD is a right angle. So diameter means I need to prove ADC is 90 degree. So how will I prove that? They should be equal. So equal chord subtend equal angle at the center. So the sides are equal. AD equal to BC, AB equal to CD. So opposite sides are equal. So what we can do for this? Opposite sides are equal in the quadrilateral ABCD. So they are parallelogram. So opposite angles, so they are equal. So here opposites, this is a quadrilateral where opposite sides are equal and parallel. So they bisect each other. No? So it is a property of a parallelogram. If you see that now ABCD will be parallelogram. ABCD will be parallelogram. Why they will be parallelogram? Because it is a property of parallelogram. Because in a parallelogram, whenever we talk about parallelogram, because in parallelogram opposite sides, in case of parallelogram the opposite sides are equal. Opposite sides are equal. Okay, for a parallelogram, and the diagonals are bisect each other. The diagonals bisect each other. The diagonals may or may not be equal. So if diagonals are equal, that parallelogram become a rectangle. If diagonals are not equal, then that parallelogram become a rhombus. So it means ABCD is a parallelogram. It means it means ABCD. It means ABCD is a parallelogram. So if ABCD is a parallelogram, then if ABCD is a parallelogram, So for a parallelogram, opposite angles are equal, no? So for a parallelogram, opposite angles are equal. Opposite angles are equal. For parallelogram, opposite angles are equal. Opposite angles are equal. And you know, cyclic parallelogram is always rectangle. I think everyone by this time should understand. So angle B is equal to angle D, and the sum of angle B plus angle D is 180 degree. So angle B plus angle D, that will be equal to 90 degree. So you need to understand that the cyclic parallelogram is always rectangle. You need to understand that the cyclic parallelogram is always a rectangle. You need to understand this part. So, so you understand, no? And if the rectangle, then all angles are 90 degree. So it's proved. Okay, question number 8. See the question number 8. Now, see question number 8, everyone. You can pause the video anytime. Whenever you get the question, first pause the video, try to do the question from your end. Then, in case of doubt, refer the solution. So, the bisectors of angle A, B, and C of a triangle ABC. So, the bisector of the angle ABC of triangle ABC. So, so the bisector of angle ABC of triangle ABC. So the angle bisectors. So the angle bisectors. The bisector of angle A intersect at D, E, and C intersect at the point D, E, and F respectively. Okay. So this is the case. So prove that angle DEF. Prove that the angle DEF. 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 Now you see this. This is B by 2. B by 2. Now you see this. This is B by 2. So this will be also B by 2. Same angle in the same arc are equal. This is B by 2. 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 Now, okay, now this is B by 2. This is A by 2. This is A by 2. This is, so this is, see this angle. 1 minute, let me search. This is C by 2. 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 Angle DEF. D angle DEF will be equal to A by 2 plus B by 2. So this angle on the same arc are equal. So now this you can write as, that the sum of angle A plus angle B plus C is 180 degree. So you know that this is equal to 90 minus angle C by 2. So this is 1 minute. So see this is triangle ABC. This is ABC. So the bisector of angle ABC intersect on the circumference at D at DEF. So it's very simple. Prove that the angle of the triangle DEF. Prove that the angle of the triangle DEF FDE. So if this is the angle, so this is the angle. So this is C by 2. This is C by 2. This is B by 2. This is B by 2 angle on the same arc. So you can see that angle. You can see that angle FDE. Angle F. Sorry, angle. You can see that angle FDA will be equal to the angle FCA. FDA will be equal to the angle FCA. So that is equal to C by 2, angle C by 2. And then you can say that angle AD is equal to the angle ABE, that is equal to angle B by 2. So, so the angle FDE will be equal to C by 2 plus B by 2. That will be equal to 90 minus A by 2. So similarly, I can prove all the other angle. So similarly, I can prove that the angle FB, that will be equal to FDE, that will be equal to A by 2 plus C by 2. That will be 90 minus B by 2. That will be 90 minus B by 2. And similarly, what angle left? Similarly, angle DFE, that will be uh, A by 2 plus B by 2. So that will be 90 minus C by 2. Simple. So you can say FEB will be equal to FCB. So FEB, so FEB is equal to FCB. FEB will be is equal to FEB is equal to FCB. That is equal to C by 2. And then BED, and then BED is equal to angle BAD, that is equal to A by 2. So this is equal to A by 2. This is equal to A by 2. So like that you can do all the calculation, very simple. Question number 8 is very easy. Okay, then question number 9. Two congruent circles intersect each other at point A and B. So two congruent circle. Question number 9. So two congruent circle. Two congruent circle intersect at the point P and Q. Two congruent circle intersect each other at the point A and B. Two congruent circle intersect at the point A and B. Okay, so through A any line segment PAQ is drawn so that PQ lies on the circle. So A any line segment PAQ is drawn. PAQ is drawn such that PQ lies on the two circles. Prove that BP is equal to BQ. You need to prove that BP is equal to BQ. To prove, what you have to prove? You have to prove BP is equal to BQ. And given they are congruent circle means the radius are same. Okay. Okay, suppose the center of the circle is O dash. This is O dash. Okay. Now what you do? Join this. Now join this. Okay, so the center. Hmm. Hmm. Now the circles are congruent circle. Congruent circle means they have equal radius. Means R1 is equal to R2. And so it means this. It means OA O dash B is a rhombus, no? It means OA O dash will be rhombus because all side will be equal because this is R. So this will be also R. This is R and this is R because they are congruent circles, so the radius will be equal. So OA O dash B would be rhombus. So if they are rhombus, so all sides are equal. So here triangle OAB, that will be congruent to the triangle O dash, then AB, O dash AB, they would be congruent by SAS congruency. So by SSS congruency, so they are congruent. So if they are congruent, so then it means angle AOB will be equal to the angle AO dash B. So if they are equal, angle AOB is equal to angle A dash B. So that means so they are the double of angle APB. So AOB. Okay, so they're double, no? So not half, double. They're double. I can say twice of angle APB will be equal to twice of the angle AQB. So because AOB and A dash B, AO dash B, so they are equal because the triangles are congruent. So then you know that angle formed at the center of the circle is double of the angle formed on the circumference. So I can say that the angle APB, so it angle APB will be equal to angle AQB. APB is equal to AQB. So if they are equal means, so it means if they are equal means, so what that means, it means BP is equal to BQ. Means BP is equal to BQ. Question number 9. Now question number 10. Last question. Last question. Question number 10. This is the last question. So this last question. If in any triangle ABC, if the angle bisector of angle A and the perpendicular bisector of BC intersect, prove that they intersect on the circumference of the triangle ABC. So in a triangle ABC, this is question number 10. So this is the triangle ABC. So in triangle ABC, the angle bisector of A so if the angle bisector of A and the perpendicular bisector of BC intersect, and the perpendicular bisector of BC intersect. So perpendicular bisector of BC intersect. Perpendicular bisector means given of BC intersect, given that BE is equal to EC, and suppose this is O dash, BE is equal to OC, and OE is perpendicular to BC because it's a perpendicular bisector. Okay. So let the center of circle is O. Let the center of the circle is O. Suppose this is the center of the circle. So if this is X, this is X, so this will be 4X. Construction join BD DC. Now it is given. Now it is given that angle BAD is equal to angle DAC because AD is a perpendicular because AD is the angle bisector. So because it is given, so it means BD will be equal to DC, means arc. So the arc or chord, whatever you say. So BD will be equal to DC. Okay, so the arc BD will be equal to, so the arc BD will be equal to the arc DC because the angles are equal. Okay, so now now okay, now we can see the triangle. Now see the triangle O dash E B. Okay, so that would be congruent to the triangle O dash E C, because both triangle would be congruent. So the congruent means B is equal to EC. That is right, because the angle bisector, they are perpendicular bisectors. So it is perpendicular plus BE is equal to EC. Okay, and then you know that very important theorem, that the perpendicular bisector, you know that very important theorem, that the perpendicular bisector of the chord, perpendicular bisector of the chord of a circle always passes through the center. It always passes through the center. You know that it always passes through the center. So it means O or O dash is the center of the circle. Are you getting me? So there's no point called O. There's no difference between O and O dash. Okay, so both mean same thing. So here, so in this triangle, so here, so in this triangle, so here in this triangle, E, B, C, this is D. Okay, this is O. So means O is the center of the circle. Okay, so O is the center of the circle. So if O is the center, so here O is the center. So if, because O is the center of the circle, I already have proved that, already have proved. If O is the center of the circle, so then OB will be equal to OD because they are the radius. So if OB and OD are radius, means D lies on the circumference of the circle. D lies on the circumference of the circle. D lies on the circumference of the circle. Means D, which is the point of intersection, which is the point of intersection of angle bisectors and perpendicular bisector, point of intersection of angle bisector and perpendicular bisectors lies on D. Here you know that BOC is double of angle BAC. No, you know that part. And these triangles are congruent. These triangles are congruent. This and this is perpendicular. This is right angle. This is perpendicular. So so because triangle here, the triangle here, the here, because this and this, so you have to understand. Once you understood this BOE, once you understood that BOE is congruent to the triangle COE, once you understood they are congruent, means OB will be equal to OC, means OB is equal to OC because of congruency. So OB is equal to OC and OB will be equal to OD because O lies on the center of the circle, because this line, this perpendicular bisector, whatever is the perpendicular bisector, it always passes through the center. Okay, so the perpendicular bisector always passes through the center, means this is equal to OD because perpendicular bisector always passes through the center. So OB is equal to OD equal to OC, means O is the center of the circle. So if O is the center of circle and this lie, it means D lies on the circumference of the circle, which is the point of intersection. So here in any triangle ABC, if the angle bisector A and the perpendicular bisector BC intersect, prove that they can intersect on the circumference of the triangle ABC. So yeah, they are intersecting at the circumference of the triangle ABC, which we have proved here. So here the angle bisectors and the perpendicular bisectors both are meeting at the point D, and D is the point of intersection of the angle bisectors and perpendicular bisectors. The point where all the perpendicular bisectors meet, that is called circumcenter, where the point where all the angle bisectors of the triangle meet, that means in center. Okay, anyone have any doubt? Anyone want to ask any question? Any doubt, anyone? So I hope you have understood what all we have done so far in this session. So, uh, so the purpose of having this session is to discuss the exercise problems which are optional in nature, So exercise 10.6, which is optional, and you should solve this problem just to do the revision of the concept what you already learned, and to revise the concept what you have studied till now. So it is important that you should refer this material and try to solve the problems. So that way it would help you in the main exam preparation time. So guys, I hope you have learned something from this session. So circles all together is very important topic. So that was the intention to enlighten yourself with certain basic knowledge on circles. At the same time, those who already well versed with the concept of circle, that would be revision for them. So guys, it's time to say goodbye to all of you. Thank you everyone. See you all.